In this example, I'm going to go ahead and solve this polynomial equation. And it looks like I have all the terms on one side equal to 0, which I need it to be that way. So then this left side, there's several strategies here, but I always want to try to factor it first. And it looks like I can use factoring by grouping to get us going. So out of the first set here of 3 terms, it looks like I can factor an x to the 4th out. And when I do that, I have x squared minus 4x plus 4. And out of the second group of 3 terms, it looks like I'm going to take just a minus 1 out. So I'll have x squared minus 4x plus 4. Okay, well this is great because these leftovers are the same, which I can factor those out as x squared minus 4x plus 4. And then I'll multiply that by the greatest common factors I took out, which were x to the 4th minus 1. Okay, well, I have some nice factorizations here. This one is actually going to be a perfect square. We have x minus 2 times x minus 2. And then here I have difference of squares, which will end up being x squared minus 1 and x squared plus 1. All right, well, actually, each of these can be factored down even more. So let's go ahead and write this first one as a perfect square. X squared minus 1 can factor as a difference of squares, like I said, x plus 1, x minus 1. And then this is the sum of squares, so that's going to factor over complex numbers. So I'll have x plus I and x minus I. So it looks like I have 6 roots, 1, 2, 3, 4, 5, 6. And of course, my degree up here was degree 6, so I knew there were going to be 6 roots. Not all are unique, of course, because I have this multiplicity here. But I can now take all 5 of these unique roots and set them equal to 0 using my 0 property of multiplication. So x minus 2 equals 0, x plus 1 equals 0, x minus 1 equals 0, x plus I equals 0, and x minus I equals 0. And to finish up, then, I have x equals 2, x equals negative 1, x equals positive 1, x equals negative I, and x equals positive I. So to write them all together then, I have x equals 2 plus or minus 1 plus or minus I. And so I have solved now this initial polynomial equation. And the first step was to factor by grouping. And then I had that split up into 2 other expressions here that I was able to then factor in and of themselves. And I ended up with the solution here with 5 unique roots.